Hey everyone, and welcome to This Explainer. I am incredibly excited you're here with us today because, well, we're about to explore some seriously unbelievable hidden mechanics inside the human brain. We're going to take a deep dive into the underlying nuts and bolts systems that dictate exactly how we perceive the world, how we somehow manage to push through incredible adversity, and ultimately how we literally possess the power to rewire our own minds.
Okay, let's dive into this. Here is our cognitive roadmap for today. First up, we'll look at the hidden power of smell. Second, we're exploring the brain's actual willpower center. Third, we'll break down the art of pattern recognition. And finally, number 4, rewiring through neural plasticity.
All right, let's jump straight into section 1, the hidden power of smell.
So I want to kick things off by completely shattering a myth that I guarantee almost all of us believe. Let me ask you this directly. Is a bloodhound's sense of smell really better than yours? Now, if you're like most people, you're probably thinking, obviously, it's a hunting dog. But the science actually reveals a much more fascinating reality about what's hiding right there inside your own head. Here's the crazy part. If we look at the actual pixel resolution of our olfactory receptors, like the pure biological hardware inside our noses, it is virtually identical to a bloodhound's. Seriously, the difference isn't in the raw sensitivity of those receptors. Instead, dogs just, mechanize the act of smelling better. They sniff at a way higher frequency, and their noses have these physical slits that create little air vortices. That traps the scent for a longer exposure time. It's kind of like keeping your eyes open longer so you can see better in a dark room. But your baseline biological ability to smell, fundamentally just as sharp. Need proof? Researchers over at UC Berkeley conducted this absolutely incredible experiment. They took regular humans, blindfolded them, put thick gloves on their hands, and completely removed all access to their dominant senses of vision and touch. Then, they asked them to track the scent of chocolate that was buried 7 inches underground out in an open field. And the result? No joke. Without visual distractions, these human subjects dropped right down to the grass and successfully tracked the scent trail perfectly, just like a hunting dog. It proves we have this incredible primitive scent tracking potential. It just gets completely drowned out because we rely so heavily on our eyesight.
Now, why is smell wired so deeply into us? Well, it's because our nervous system actually evolved to be a chemical sensor way before we were ever light sensors. When you encounter a sudden, intense smell, your brain doesn't have time for complex philosophy. It immediately simplifies your motor response into just 3 primitive categories. You either move forward toward an appetitive, yum scent, you retreat in a total rush from an aversive, yuck threat, or you just pause to evaluate something unknown. There's zero overthinking here, it is just raw biological survival. Let's move to and see how this builds when we sense real danger. Imagine you catch a whiff of a highly aversive scent, say an incredibly strong chemical like smelling salts. A lightning-fast cascade kicks off in your body. Your olfactory bulb detects it, completely bypasses your conscious thought, and routes the signal straight through to the amygdala, which is your brain's threat center. Boom. That fires a signal all the way down to the adrenal glands sitting right on top of your kidneys. The result? A massive, instantaneous release of adrenaline rushing through both your body and your brain, priming you to just move. But that adrenaline rush doesn't act alone. It works in this tightly knit chemical gang right alongside dopamine and noradrenaline to drive our motivation. And that brings us to this brilliant insight from neurobiologist Robert Sapolsky. He says, dopamine is not about the reward of pleasure, it's about the pleasure of pursuit. These chemicals don't just wake us up, they give us the laser-directed focus and the intense drive to pursue challenges, hunt for resources, and actually survive out there in the physical world. Okay, let's shift gears. Section 2, the brain's willpower center. So now that we know how powerfully we perceive the outside world, how exactly do we internally process challenges when things get really difficult? Well, it turns out willpower isn't just some abstract fuzzy concept, it actually lives in a very specific place. Enter the anterior mid-cingulate cortex, or the AMCC. You can literally think of the AMCC as the physical hub for your willpower. When surgeons stimulate this highly specific part of the brain in awake patients, it's wild. The patients universally report feeling like a storm or a massive challenge is coming, but it's accompanied by this profound internal desire to lean into it and push through. It is literally your brain's engine for doing hard things. And this brilliantly illustrates what happens when neuroscientists measure the actual physical volume of the AMCC. The data shows exactly how this area adapts to your daily lifestyle. Doing hard things, specifically things you absolutely do not want to do, physically increases the volume of this brain area. It grows like a muscle. Conversely, if you just default to comfort or abandon a difficult task like a diet, the AMCC literally shrinks. Now, here is the real kicker. Even if you do something highly strenuous like heavy deadlifts, if you actually enjoy doing it,
The AMCC volume doesn't change at all. It only grows when you push through internal resistance.
This brings us to a super fascinating group of people known as superagers. These are individuals who somehow maintain incredibly sharp cognitive functions late into their 70s, 80s, and beyond. So what is their universal shared trait? You guessed it, a physically larger AMCC. By constantly leaning into resistance throughout their lives, whether that's plunging into freezing water, solving brutally complex puzzles, or exercising when they'd really rather just sit on the couch, they actively build this willpower muscle. And that physical and mental momentum translates directly into holding on to their cognitive abilities far, far longer than average.
Moving right along, Section 3, the art of pattern recognition.
Building on our understanding of mental endurance, let's look at how our brain uses its incredible processing power to spot patterns and survive in really complex environments. We essentially do this on two vastly different levels. On one hand, we have unconscious genius. Think of a master boxer, right? Like Floyd Mayweather. Through relentless drilling, his brain subconsciously recognizes the tiny micromechanics of an opponent's shifting weight, which allows him to literally slip a punch fractions of a second before it lands. On the other hand, we have conscious evaluation. In today's digital world, our safety often relies on highly conscious threat detection, like using critical thinking to spot a deceptively edited audio clip or highly manipulated political media that's designed to manufacture outrage. The stakes might look different, but the brain's ultimate goal is exactly the same: detect the pattern, survive the threat.
And what's really interesting about this slide is this single tiny statistic, 10%. Psychologists note that a mere 10% of the population are highly manipulative, high-conflict individuals. Yet this small fraction causes the vast majority of severe societal and interpersonal issues. Honing our pattern recognition, like actually listening to those split-second spidey senses when someone acts in a way 90% of healthy people just wouldn't, is absolutely essential for protecting our own peace and our physical safety.
All right, we have arrived at Section 4, rewiring through neuroplasticity.
So far, we've talked about tracking sense, building up physical willpower, and sensing behavioral threats. And that brings us to the ultimate biological superpower that ties all of this potential together: neuroplasticity. This is the brain's remarkable, almost magical ability to rewire its own circuitry in response to new experiences. Now, when we're kids, our brains are incredibly plastic. We just absorb languages and skills completely passively. But here's the catch. Unlike kids, adults cannot rewire their brains passively. As adults, we have to intentionally trigger a very specific neurochemical environment to force that window of plasticity to open up.
To actually achieve this rewiring in adulthood, you have to follow exact biological steps. First, you absolutely must spike neuromodulators, like adrenaline and dopamine. And like we talked about earlier, you get those spikes by doing challenging, highly alerting things. This sudden chemical spike creates a youth-like brain milieu, or environment, which basically screams at your nervous system, hey, something vital is happening. Only then, in step 3, can you effectively target the specific cognitive or physical habit you're trying to learn or rewire. Without that initial chemical spike of alertness, your adult brain simply refuses to change. And this actually brings us to the absolute frontier of neuroscience. Right now, clinical trials are utilizing targeted neurotherapies, which include compounds like MDMA and psilocybin, to treat severe trauma and PTSD. And they work exactly on the mechanism we just discussed. These compounds dramatically spike serotonin and dopamine, forcing that neuroplastic window wide open, so the brain can safely decouple from traumatic loops. Now, while the data is genuinely striking and offers immense potential for remission, scientists emphasize a crucial point. Strict clinical safeguards, like having highly trained professionals present, are entirely paramount to ensure patient safety during this incredibly vulnerable state of rewiring.
So, the crucial point is this: your brain is a dynamic, highly adaptable machine, and it responds directly to the demands you place on it. Whether you are tracking a scent, spotting a behavioral threat in the wild, or seeking to literally grow the volume of your willpower center, the power is entirely in your daily choices. So I want to leave you with this provocative question to chew on today. What hard thing, that thing you really don't want to do, will you choose to do today to grow your brain? Thank you so much for joining me on this explainer. Keep learning, keep pushing your limits, and I'll catch you next time.